So this is the last example problem for this topic. It's called parsing a Boolean expression. So the question asks us to return the result of evaluating a Boolean expression defined as following. So a single character t is a Boolean expression. It will be evaluated to true. And the single expression of f, the single character of f will be evaluated into false. And if we have a exclamation mark followed by parentheses and then inside the expression, this will be evaluated to the logical negation of the inner expression. We also have an and. So and followed by a parenthesis and then two or more expressions in here, and will be evaluated to the logical and. So I guess in C or Java, typically we use this as a binary operator, but here we use it we can operate multiple expressions and them all of them together. And similarly, we have or. And one thing to note is that there are no white space in this syntax, so that makes the code slightly easier to write. So we are basically given input as a string, and we are supposed to compute true or false, a Boolean expression. So this is also a question I recommend you to really spend some time thinking about it, see how you would do it. So far we've seen at least 3 different problems where we evaluate the expression. So expression has operators, and they are of they differ in where the operators are relevant in related to the operands. For example, when we add, then there are two number we want to add, two expression we want to add their result. So we've seen 3 different ways. So the first one we saw in evaluate reverse Polish notation problem, the operator are at the end. So we see first number, and then we see, for example, 3, 5 plus, and that gives us an 8. So the way to deal with that kind of expression is to use a stack. So we push number in, and when we see operator, we know there should be 2 numbers in the stack that we want to apply the operator. And we've also seen operator in the middle in the basic calculator 2 problem. So we can see 2 plus 3 times 5. So we also use stack to process that. So when we see an operator, then depending on the type of the operator, we may decide to either just push things on the stack, or reading number push on the stack, or when it's multiplication division, we actually pop one thing from the stack and then we read the next number and then we do the operation and push the result. So we also use stack to store the part of things we have parsed, but we haven't been able to do anything to it yet because the operator precedence, so we can't do addition subtraction yet. So in this question, we have operators in the beginning. So each of these, the exclamation mark, and or, ampersand, and this vertical bar, they are essentially operators. And they can take multiple expressions as they apply to multiple at the same time by using parentheses to denote which expressions this will apply to. So while we can handle this kind of expression using stack as well, because the operators are at the beginning, it's actually easier to handle using top-down recursion. So we'll be still using stack, but then the stack will become implicit. So we're not we don't explicitly maintain a stack. The stack will be used to support the recursive function call. And the reason is, when we see an operator, we know exactly what to expect next, and then we can parse accordingly. For example, if we see an ampersand in the beginning, we know next one should be a parenthesis, and then there should be expression after that followed by a comma. There's another expression after that, followed either by a comma or a close parenthesis. If it's comma, then there should be another expression. If it's a close parenthesis, then we're done with this. We should end all of these values together. So whenever we see we read the first character, we know exactly what to do. So in that case, it's actually easier to use the top-down recursion, and we're going to see the code for actually doing that. So this is my code. So this part is just set up how to do it. So the detail, the main most of the code are in this eval function. So what it does is it will evaluate expression starting at the current position until it parses a full expression. Then it will stop. And in the meantime, it will also move this IND. So this is a pointer. This is the index of the pointing to the expression. So we try to parse the expression starting from that position, and we will stop when that expression ends, and then we return the value. And then this is the outermost function, the public function. What it does is just assign expression to the class variable, to the instance variable, and then initialize the value to 0, and then simply call eval. So we start at 0. The whole thing should be an expression, and we return the result. So the main logic are in the eval function, and the eval function is on 2 slides. So this one and the next. So the first thing we do is we read in the character, and after we read in, we move the pointer. We increment the end. So then the code follows very much the definition here. The code is essentially a case analysis, whether we are seeing T, F, exclamation mark, ampersand, or vertical bar. So if it's T, then we should just return true. That's the expression. So the expression is over. If we see F, we return false. And if we see an exclamation mark, so remember this is the syntax, then we expect the next one will definitely be open parenthesis. And follow that will be expression. And then follow that will be close parenthesis. So here, because we are guaranteed that the string given satisfy the grammar, so I know the next character is the open parenthesis. So I don't even read it. I just increment IND to skip it. And then I will call eval because I want to parse this expression. The result, I do negation to get the answer. And after the expression, I go one step further to skip the close parenthesis, so that the IND will point at the right position after this, and then I return answer. So the rest of the code handle and or. So when it's end, this is what we expect to see. So we will first skip the open parenthesis, and then we evaluate expression. So we consume one expression. Then the next one would be either a comma or a close parenthesis. So I will read the next one. If it is a comma, then I know there should be another expression, and the result should be ended with the answer. So that's my code. And otherwise, when I get out of the loop, then that means I read a character that's not a comma. Then it has to be the close parenthesis. So at which point I just return the answer. And the logic for or is exactly the same, except that instead the end equal, I do or equal. And that's it for this for this problem. So we use this when we call eval in the beginning, it will call the function itself. Recursively call itself to evaluate sub expressions. So until when we reach true and false, that those are the kind of the leaf if you parse the expression into some tree structure, and then we will return from this and then get a result for the whole expression. Okay.